Small multiples displays are a common data visualization design pattern in which a collection of data is displayed in a grid of small visuals for easy comparison and identification of trends. Small multiples are usually displayed on screens, but adapting them to immersive spaces in augmented and virtual reality allows us to present three-dimensional datasets using three spatial dimensions. Here we see an example use case of aircraft trajectories as trails of latitude, longitude, and altitude positions. Such immersive spaces present new design options for small multiples. For example, here, the small visualizations are arranged in a semicircle around the viewer to equalize their distance to the viewpoint. The viewer need only turn their head to change their focus to a different visual. But this is not the only layout option. We present a design space of alternative layouts for immersive small multiples. We consider layouts with 2 versus 3D grids, curvature flat through to full circle, tall or wide aspect ratio, and orienting small multiples uniformly or towards the viewer. We propose a shelves metaphor for immersive small multiples displays, like the shelves of a display case. We also consider options for interacting with small multiples as part of our design space exploration. Here we allow the viewer to adjust the width of the shelves, and the small multiples automatically rearrange. Other layout dimensions are adjustable too, such as curvature, height, and positioning of the shelves relative to the viewer. Apart from setting up the layout, a number of interactions are also required for data analysis tasks. We explore several ways to rotate the visualizations, and also different types of brushing to highlight and compare specific elements of visualizations across all multiples. Interacting with the axes of visualizations allows us to select and highlight ranges of data elements. Bimanual interactions with the axes allow both the start and end of the range to be specified simultaneously. You can interact with 2 axes at once to make a 2-dimensional range selection, or interact with the volume inside the visualization to create a range selection across all 3 data dimensions. Range selections can also be fine-tuned. A ruler tool assists analysts with precise comparisons. We evaluate aspects of our design with 2 studies. Our participants completed 2 types of tasks, using 2 different datasets, and 3 degrees of layout curvature. We find that flat layout is the most performant condition, but it requires more movement. Half circle provides a good compromise between reducing walking distance and forcing users to turn, and it was the most preferred.